So welcome back, guys. Today I'm going to discuss about the Bernoulli's principle first. Then I will explain our applications on Bernoulli's principle. So coming into Bernoulli's principle, before going to the Bernoulli's principle, so we have to complete a small topic, that is, so types of flows means fluid. So there you can see steady flow, non-steady flow. So this is steady flow. Here example I have given. So this is uniform and unsteady flow. The steady flow means the speed means for steady flow, there is no change in the speed. dv by dt is equal to 0. So after some time, the water flowing in the water tube. So initially and finally, the speed of the water, both the ends will be different. But in the middle, the speed of the water in the tube, you can't see that is flowing. It is constant. Therefore, dv by dt is equal to 0. The same way, dp by dt is also 0. There is no change in the pressure. And d rho by dt is also equal to 0. So that is steady flow. With respect to time, velocity should not change. So this line is called steady flow, streamline flow will come. So this line also steady flow. This line also steady flow. Because here velocity 3 meter second inwards, here also velocity 3 meter second. Here 2 meter second inwards, 2 meter second. 1 meter second. But it is non-uniform speed, non-uniform motion of the fluid, non-uniform fluid. So here coming into uniform fluid. 1 1 1 2 2 2 or 2 1 2 1 2 3 like that you can take. So this is unsteady. So here speed is 1 meter second inwards. Here 2 meter second inwards. The uniform and unsteady. So rotational, irrotational. So irrotational motion means net angular momentum is 0. So across the fluid there is a one wheel I am keeping means it is not rotating. So that is irrotational flow. It is rotating now, that is rotational flow. Compressible and non-compressible, incompressible or incompressible flow. So already we explaining about the Poisson ratio we studied about. The compressibility is reciprocal of compressibility K is reciprocal of bulk modulus. So B is the bulk modulus, K is compressibility. In some books they will take K is the bulk modulus and you can take C as a compressibility. K equal to 1 by C. K is bulk modulus, C is compressibility. This reciprocal of K is called compressibility. So for volume means the bulk modulus will study in all types of matter, that is solid, liquid and gases. We studied already in velocity. So in for solids compressibility is very less, but gases compressibility is more. So gases can compress the more volume, but solids cannot be. So that example syringe you take sand, water and gas you fill, you are pressing the now by closing one open end or needle end and pressing from the pump side. Gas means you can press up to some level by applying the same force. Liquid means very less and sand not possible. So where the compression is possible in gases. So that point is clear. And compressibility is 0, then Poisson ratio is equal to 1 by 2. So if there is a strain, Compulsory there is some compression or expansion will be there. Means change in the volume is there. If change in volume 0, then only Poisson ratio is 1/2 will come, but it is not possible where there is a stress or strain happens. Right. So viscous and non-viscous, viscous means the layer to layer, the friction means the rate of flow is top layer will go more speed than bottom layer of the river flow, means in a flow. So top layer speed is more than bottom layer, means there is a friction between layer to layer. This is called viscous. So example, honey and kerosene you take. Throw a one stone in honey and kerosene. So the stone in the kerosene will move faster honey than in honey. That means the friction is more on stone by the honey than kerosene. That's why you can say honey is viscous than kerosene. If you take water and kerosene, water is viscous than kerosene. Water and honey is viscous. Means that experiments will give the viscous and non-viscous. Non-viscous means they can evaporate easily, violate easily, evaporate. Okay, non-viscous liquids. So that is one case. So this is about the types of flow. So here I have given irrotational flow means it is not rotating. A wheel placed in across the flow, river flow or fluid, which is flowing, streamline. So that it is not rotate, then it is called a rotational flow. All right. So now before going to Bernoulli's principle, very important is equation of continuity. So according to equation of continuity, the rate of flow of fluid dm by dt or a1 v1 or dv. dm by dt means dv we will call. So this will be constant. Means two different points you consider. Whatever the cross section, whatever the shape, but the rate of flow is same. How much water is entered or how much the rate of flow is there at one point. So other point also the same rate of flow should be. So it will be very useful in solving the problems related to venturi meter, velocity of flux, siphon and all. So now you see clearly here. So A1 V1 equal to A2 V2. This is equation of continuity. Bernoulli's principle. So Bernoulli's principle giving the relation between sum of three energies. Is one of the conservation of energy. This is, but it is not conservation of mechanical energy. The mechanical energy means only two energies are there. One is kinetic and potential only. It is the sum of kinetic and potential is mechanical energy, no in work core energy. So here we are adding third energy, that is the pressure energy. So this pressure energy will take as atmospheric pressure or work done by the flow. That also you can take. So here consider a incompressible steady flow or unsteady flow. Both for steady flow and unsteady flow, we can apply the Bernoulli's principle, not a problem. So now this is unsteady. Here V1, the speed is V1 and entering with V1 velocity and leaving with V2 velocity. Here the cross section is A2, here the cross section is A1. So remember this is small a and capital A. One is capital A means another one is small a, or A1 and A2. So according to Bernoulli's principle, pressure energy, kinetic energy and potential energy is constant at any point. So here take first point, this is the point 1, this is the point 2. So the water entering, fluid is entering into this through this cross section of the pipe. So here is given. So whatever, however you can take, not a problem. Like this also you can take. Or this will be reversely you can take, not a problem. The pipe is, water is entering like this and leaving like this. So two cross sections are different. So speed of the flow or fluid will be automatically different. One place V1 means another place V2. So it is very clear that according to equation of continuity, rate of flow, amount of flow is constant, therefore AV is constant. So V is inversely proportional to area of cross section. So area reduced means velocity will be more. That's why whenever you are piping the water, watering the flowers to long distance where you can't go, we'll close the pipe some area. Then water will come up, speed of same amount. So this situation consider here. So in sometimes they will give only this line. When this line is giving means pressure, potential energy is equal to h rho g only happens. Potential energy is equal to at this point, the second point only potential energy is there. First point potential energy is zero. Otherwise, the ground level, from the ground level, these two pipes are in H1 and H2 height. So therefore, potential energy at point 1 is equal to H1 rho g. Potential energy at point 2 is equal to H2 rho g. So now, so V1 velocity and V2 velocity are there means there is a kinetic energy and the pressure energy also. The water is displacing dx1 in the time delta t. So let's consider dm mass here. So this dm mass is moving in each second dx displacement. Here dx1, here dx2. So velocities are different, therefore dx is also different. So let's consider work done on fluid. So that equal to force into displacement, we know. Force is equal to pressure into area. Force is equal to pressure into area. Displacement here delta x1 in 1 second of time. V1 means what? The rate of displacement. In 1 second, dx displacement is travel. Therefore, work done by the pressure energy is equal to P1 A1 into delta x1. Therefore, the difference in the pressure with dV, with the volume, is called pressure energy, or multiplication of change in pressure into dV. PdV. dW is equal to dP into dV, or PdV. Here pressure is not constant. Pressure is constant means PdV. Pressure is not constant means V into dP plus P into dP. Both will be changes. That is, in thermodynamics will come. This is. So now potential energy is equal to, we know, mgh1 minus mgh2. So in the place of m, I can write mass is equal to volume into density, dV into density into substituting h1 minus dV into rho into gh2. So now kinetic energy of m v1 square minus of m v2 square. In the m value substitute, the finally this one will get like this. The pressure energy P1 minus P2, change in potential energy H1 minus H2 of rho g, change in kinetic energy is equal to constant. So now 1 and 2 are separate. So finally, this is very, very important equation in solving the problems based on Bernoulli's principle. So that is P1 plus means P1 means pressure energy at first point. This maximum of the cases pressure energy will be atmospheric pressure. This will be atmospheric pressure. Sometimes you will give here some pressure. In the place of pressure, it will be mg by A also sometimes you have to take. So sometimes you will give the change in pressure is equal to. There will be a change in pressure between the two ends of the flow. That equal P1 minus P2 or P2 minus P1 you will give. Right? The change in pressure energy. So P1 minus P2. So now here the rho V or rho G take common. P by rho G plus V square by 2G plus H is equal to constant. Here this is P by rho G is called pressure head and V square by rho G kinetic head and H is equal to potential head. Means Bernoulli's principle is sum of three energies. One is pressure energy, potential energy as well as kinetic energy. At any point is constant or conserved. So now coming into Bernoulli's principle application, there is a Venturi meter, siphon, pitot tube, efflux, velocity of flux, Magnus effect, and dynamic lift, blood pressure, calculation of the blood pressure. All these and all are based on Bernoulli's principle. So the papers, calendar papers are flying out, and aeroplanes are moving, dynamic lift or so dynamic lift and aerodynamic lift are different. So what the difference we'll study in dynamic lift later. Otherwise, you can find out that aerodynamic lift means due to the air pressure. Dynamic lift can be the air or water pressure. So the difference in the pressure means force pressure by pressure into area equal to mgr force. So the upward pressure or the pressure difference on unit area is called dynamic lift. So that we will study in the topic. So now coming into venturi meter. So here only three steps you have to remember. One is A1 V1 is equal to A2 V2. So here the points need to remember is A1 V1 is equal to A2 V2. Similarly, the pressure energy, pressure equation, Bernoulli's equation. So P1 minus P2, pressure energy. So here the pressure energy, see if you take here A point and B point at the horizontal level, if you take here, so these points, H rho g is 0. According to Bernoulli's principle, H rho g is 0. But the difference in the pressure energy here, PA and P2, P1 and P2, P1 minus P2. The difference in the pressure energy, which is equal to the difference in the height of the liquid considered here. This is called differential venturimeter, manometer down, which one is connected with a different liquid. So this liquid can be a different density D or same density of the fluid flow here. So the density of the fluid is equal to rho. So these two can have same density or different density. Here I have considered different density. Then I can change into same density. So here connected differential manometer. It is not open, right? It is closed and with some liquid, some fluid. So now apply these equations, you will get the P1 minus P2 pressure energy, difference in the pressure energy is equal to difference in the kinetic energy. The potential energy du is equal to 0 here. Du is equal to 0 because 2 points I consider on horizontal line only. Right. So from this 2 will come this side, 2 into H rho g is equal to rho into V2 square minus V1 square. So you know very clear, here I want to find out V2 or V1. That is your wish. So if you want to find V2 means V1 substitute from the equation of continuity. You want to find out V1 means V2 substitute from the equation of continuity. V2 means V1 substitute from the equation of continuity. So in this equation. So in the Bernoulli's equation. Then you will get finally, so these are very, very important. V1 is equal to A2 into 2GH by A1 square minus A2 square. So here A1 is bigger value, A2 is smaller value. Remember this, A1 is bigger, A2 is smaller value. Here V1 is coming means A2 will come. V2 coming means A1 will come here. You understand? V2 means here A1 will come. So V1 means A2 will come. That is only difference. And now, because in the root value negative should not become. So here A2 minus A1, A1 square minus A2 square will take. A1 is bigger one I have taken. So now, here in this equation here I have taken Here density is rho, and here also density. Same liquids I have taken. The flowing liquid and the manometric liquid is both have the same density. So then formula is equal to 2GH by A1 square minus A2 square into A2. V1 means A2, V2 means A1. So you have to remember these formulas while solving the problems. Every means instead of remembering this, applying the Bernoulli's principle to each point is very, very important, because in some of the problems he will give some conditions. So to apply that conditions, you have to practice the number of problems applying the Bernoulli's principle. P, pressure energy, kinetic energy, and potential energy at two different points, the bottom point and top point, or any given points, any given 2 points, have to apply the Bernoulli's principle. Pressure energy, kinetic energy, potential energy. Then only it will be easy. So if you, however, remember and using this formula, sometimes you will do mistake, and these are not always suitable equations for solving all the problems. So yeah, right. So that's why to remember only these formulas, and this is solving and how to approach. This is only approach I am giving. Right here, see. For example, here the manometer liquid have different density, and the fluid in the this venturi tube is different densities. Then the formula will be, here densities will change. So then the formula will be like this: the V1 equal to A2 into 2GH sigma by rho. So here sigma and rho I have taken while I am writing, but here you can take D. So this is D will come here. Monometric liquid, here D will come by the liquid density in the venturi tube. So A1 minus A2 square. So now sometimes you will ask rate of flow Q. Q is equal to AV, the rate of flow, or that equal dm by dt. So the rate of flow means A1 V1 or A2 V2. Therefore that equal to A1 A2 into same formula we support. So instead of differential manometer, so simple manometer, open manometer I am connecting at two, means outlet and the inlet. So this bigger, wider tube is called inlet, and the smaller tube, uniform smaller tube is outlet, right? So now here two liquids I have considered in open manometer. Two liquids have same density, means this liquid only will be raised to separate this pressure, means to safeguard this venturi tube or this type of arrangement from avoiding the pressure. So excess pressure, right? Difference in the pressure. The difference in the pressure is equal to, here these 2 points, consider any 2 points. So the difference in pressure, is equal to H rho g here. So depends on this pipe and wideness. So how much pressure difference is creating here. If not, that pressure difference is not managing, this pipe, middle pipe outlet can be broke. So then the system has to stop working. If in big machineries, that is why they'll construct like this, right? So there is a manometer, open manometer is connected. That pressure difference, however, is occurring here, that will be settled by the rising the liquid in this tube. Therefore, means it is balancing the H rho g, the pressure difference PA minus PB, or PA minus PB, or P1 minus P2 is the pressure difference, which is equal to H rho g. Therefore, H rho g is equal to of change in kinetic energy. Potential energy is 0 here. Therefore, change in kinetic energy. So that equal to V1 V2. Similarly, that is V1 into root over V1 I am finding means A1 square minus, in the place of V2 I am substituting V1, right? Therefore, A1 square minus A2 square by A2 square. So that will become, so after substituting, this is the formula for rate of flow, and here both the densities are same in the open manometer or simple manometer. So now pitot tube. The pitot tube is used to find out the velocity of flow or rate of flow. So now in this, so 2 points, consider A and B. So at A velocity is equal to VA. I want to find out that is the velocity of flow. At VB velocity is equal to 0. The point A in the h naught distance from the free surface and point B is in the h plus h naught distance, overall distance. So now, according to Bernoulli's principle apply for 2 points. Coming into first point, kinetic energy is there, potential energy is 0, the pressure energy is equal to PA. Therefore, H naught rho g, pressure energy is H naught rho g, pressure energy is PA, H naught rho g and half rho into VA square or V square. So that is equal to here velocity is 0, only potential energy is there, that is equal to H plus H naught into rho g. So now there V is equal to 2gh, H naught rho g get cancelled, V is equal to 2gh. So here H, remember the velocity of flow, river flow or fluid flow or gas flow depends on the height of the pitot tube above the surface. Okay, height of the pitot tube above the surface. So now here H is equal to above the surface. However, that means it is independent on how much depth you are placing. So that means depends on the depth, the height will be raised here. That is the different. Means you can tell me, sir, in the initially pressure increases, depth increases, pressure increases. We studied now. So then velocity also either decrease or increase. That depends. But how you are telling it is independent means, so depends on that pressure only the liquid rises in a pitot tube, right? So that He value depends on the pressure, represent pressure at the different points or different velocity. So that velocity represents this height. Therefore, V equal root 2 the H. It depends on H, not on the how much depth inside the liquid. The velocity of rate of flow, right? So now, so any one point I want to find out means this H value vary. So that will be substitute here means you will get velocities, right? So now velocity of efflux. So here one more explanation I have given for pitot tube only. So here also you can check this example. So 2 points, consider any 2 points, A and B points. So pressure at A minus pressure at B means pressure energy is equal to H rho G. And applying the Bernoulli's law, PA plus half rho d V square equal to P. So it's up to now, you'll get V equal to 2H rho G by D. So this is for gas. Means velocity of the gas. Finding the velocity of the gas is by using pitot tube. V equal to root over 2H rho G by D. HDR, D is density of gas and rho is density of the liquid in pitot tube. So now velocity of efflux. So efflux is a small opening at the bottom of extreme bottom of the open tank. Efflux is what? Extreme bottom of the hole at extreme bottom. The hole at bottom. Maximum bottom. Or on the wall. Okay. That is efflux. So that depends on the height. The velocity of efflux depends on the height. V equal to 2gh will come. That equal depends on the height of the hole. In what height it will be there. So now 2 points consider. First point and second point. So at the first point, pressure is pressure energy is equal to atmosphere only. So very important. This is velocity of efflux. Sometimes they will give here mass, some mass. 5 into 10 power 11, 3 into 10 power 3, 5 into 10 power 5 kgs, 3 into 10 power 3 into 10 power 3 kgs. So like that some mass 25 kgs. So like that they'll give some mass here. So then pressure energy is there. Mass is placing means pressure energy acting. That equal to mg by A will consider. So here atmospheric pressure at this open atmospheric pressure. There is no mass because of this hole. The water is coming down. There is no even mass also, not there mass also. So why it is coming out means because of atmospheric pressure. So here pressure energy is equal to both the sides atmospheric pressure. It will be cancelled. So apply the Bernoulli's equation. You will get formulas like this. So for Venturi tube. So this is about Venturi tube applications, petard tube, and velocity of efflux, Bernoulli's principle, equation of continuity, flow. Okay, these are the three applications, and remaining applications also same like this only. Pressure energy applying, the spinning of the ball, Magnus effect, blood pressure. These are all you can study and you can find out, or you can note the point some point. So like these are common phenomena in Bernoulli's principle.